Okay, hello all of my Matric learners. This is Matric Question Mondays. Last week on Matric Question Mondays, we worked through the Gauteng Department of Education's preparatory examination, September 2015, question 1.1. So today I'm going to do the other three questions in question 1, number 1.2, 1.3, and 1.4. So 1.2 states, solve for x correct to 2 decimal places. And this is what it looks like. Now in grade 11 you learned completing the square. Can you see that this is a completed square basically? And that's just a different method for solving for x. You've got now various methods. The first one is um, getting everything to one side, zero, factorizing, and then using the zero factor law, which you learned in grade 10. And then the second one is using the formula, the quadratic formula, minus b plus minus that formula. And then the next method for solving for x in quadratic formulas is by completing the square so that you have a squared value, and then you get the square alone and everything on the other side, and you take the square root. But when you take the square root, remember to make it positive or negative, the square root, and then from that you can solve. So now here in this question, they've already completed the square. This is already in complete square form. I'm just going to get the square alone first. So I'm going to divide by 2 both sides. Yes. Okay, yet again I'm reminding you, please, when you watch these videos, don't just sit and watch them, but sit with a pen and a paper and work through the questions with me. And then the next thing, if I've got the square alone, is I'm going to take the square root on both sides. Now on this side, the square root will just cancel out the square, so I'll just have that left. On that side, if I take the square root, I must just remember to make positive or negative the square root of 9 over 2. Now the square root of 9 is 3, but the square root of 2 is not a rational number, and that's where the correct to 2 decimal places comes in. So I'm going to just use my calculator. I hope with the light you can see the screen. I'm going to try and hold it so that you can. I'm just going to work this out with my calculator. Okay, but first, before I put this in my calculator, I'm just going to take this 1 over so that I have minus 1 plus or minus the square root of 9 over 2. And then x is equal to minus 1. I'm first going to work out the plus the square root of 9 over 2. And obviously it will give me that, but please don't write that. You press this SD button so that it becomes a decimal number, which is 1.12132. So 1 point, I'm going to round off to 2 decimal places as it's stated in the question. And then secondly, I'm going to just do the one with the minus. You can actually just use the arrows, go to the plus, delete it, and then just put a minus in. Again, I'm just going to press the SD button so that I have minus 3,12. Right, and there I solved for x to 2 decimal places. Okay, now obviously you can also multiply this out, this bracket, and then get the quadratic equation, and then solve the quadratic equation from there. But hopefully you can see that's just going to be a lot of more work. This is almost solved. If you multiply this out, get everything to one side, factorize, or if it can't factorize, use the formula, you'll come to the same answer, but it might just take a while longer. But there's no problem with using another method. This will just be the better method, or the easier method for this specific problem. Okay. Then 1.3 says solve for x and y simultaneously, and they give me minus 2x plus 7, and also, let me write it on this side, y plus 5 over x minus 1 equals a half. Okay, so if I look at this as equation 1 and equation 2, I'm going to start with equation 2 because it already has y alone. Then I'm just going to substitute equation 1, where y is this, into the second equation there. Right, so I'm going to place in the place of y minus 2x plus 7 plus 5 over x minus 1 is equal to a half. Right, and then I must just now solve this. Solve for x. This is pretty basic stuff for matrics, most of you matrics. What I'm going to do is just cross multiply. So 1 times x minus 1 is just x minus 1. And 2 times that equation, I'm just going to multiply every term with 2 to multiply with that equation. So minus 4x plus 14 plus 10. And this is a basic linear equation, so I can get all of my x's on one side. X plus 5x, 4x is 5x. X plus 4x is 5x. And then 14 plus 10 is 24, plus this one is 25. And if 5x is 25, that means x is 5. Okay. And then I'm going to substitute this. You can substitute it back into any one of those and just work out y. But this one is obviously the easier one to substitute back into. So I'm just going to say, okay, substitute x equal to 5 into 1. Okay, so I've got y is equal to minus 2 times 5 plus 7, and this is minus 10 plus 7, so it's minus 3. Right, so I've got the solution. X is 5 and y is minus 3. That's my solution. Okay, and then lastly, I'm just quickly going to do question 1.4. I'm just going to make some space here for that. Question 1.4 says, determine the values of p for which the equation 3 to the power of x 1 minus p will have real solutions, right? Determine the values of p for which the equation 3 to the power of x 1 minus p will have real solutions. Okay. Now, if I look at this equation, this side is, if you think of exponential graphs, that looks like that. It has a asymptote right there on the x-axis, and it goes like this. This side will always be bigger than 0, right? It will never cut the y is equal to 0, which is the x-axis, this asymptote. You will never cut that line. It will always be bigger than that. So since this is exponential, if you're more of a graphical person, I'm going to explain it mathematically now also. Since this must be bigger than 0, then this must be bigger than 0 also, because they are equal. And then you can just from that write down this and then solve for p, which if I take the p over, p must be smaller than 1. Okay, it's pretty straightforward. If you didn't think of the exponential graph, if you look at this and you think of different values that you substitute into the x, if I make x 0, then I get 3 to the power of 0, which is 1. Okay, I'm just going to write that down, but you don't need to write it down. You can just think it in your head if you just follow my reasoning. If x for this is 0, then this expression is 1. If x is anything bigger than 0, 1, 2, so 3 to the power of 1, 3 to the power of 2, it becomes bigger, 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 right? If I make x negative numbers, I will get 3 to the power of minus 1 is 1 over 3. 3 to the power of minus 2 will be 1 over 9. And as I go smaller and smaller negative, it will always go 1 over 3, 1 over 9, 1 over 27, which is 27, 81, 1 over 81, but it will never really become negative. It will just become smaller to 0. It will just become bigger denominator fractions the whole time, that side. It will never be negative, right? Can it be equal? Can this be equal to 0 in any way? Is there anything that I can substitute into x that can be 0? No, also not. Right, so this expression will also be, will always be positive numbers only. So that means this must be positive numbers only, and then this is positive numbers only, which means that. Right, so that is Matric question Monday for today. See you next week Monday for the next Matric question about arithmetic and geometric series.